In this video, we're going to take a look at how to set up your home studio for mixing Dolby Atmos music in a 714 speaker configuration. We'll take a look at some of the gear I'm using, including my speakers and monitor controller. We'll cover some of the best practices for speaker placement, room layout, and go over recommendations you can use when you're setting up your own studio for Atmos music. We'll also be joined by Dolby's Senior Applications Engineer, Brian Pennington, for a look at best practices and techniques for tuning. Brian has tuned Atmos music rooms of all sizes and configurations. Be sure to check out the entire Atmos Music Creation 101 video series for in-depth tutorials for Atmos music creation. We're going to focus on my 714 system here, which is the recommended minimum configuration for Atmos music speaker monitoring. The guidance provided here will allow you to create mixes that can scale up to larger venues and all the way down to headphones, while offering you the greatest chance of achieving reliable translation across all outlets and devices. This includes playback environments such as headphones, soundbars, smart speakers, mobile devices, home theater setups, and automobiles. There are some general guidelines and best practices to keep in mind while configuring your Atmos music studio. The basic concepts we'll look at here are room size considerations, speaker specifications and placement, signal routing, and room tuning. Starting with room size, the optimal Atmos mix room would be 18 feet wide by 21 feet long and 10 feet high. But for those of us with home studios and working with less than perfect room dimensions, you will generally want your Atmos music room to be a minimum of 10 feet wide by 11.5 feet long and with your ceilings at least 8 feet high. These specifications will be optimal for speaker configuration and allow for proper dispersion. Here's how these measurements are taken. For the minimum layout length, 11.5 feet is the distance measured from the center speaker baffle to your rear surround line. For the minimum layout width, 10 feet is the distance between your side surround speakers. And finally, for the minimum layout height, 8 feet is the distance measured from the floor at mixed position to the acoustic center of your overhead speakers. Let's get into speaker specifications. In a 714 speaker configuration, you'll have 7 horizontal plane speakers around you. These are also known as your surround speakers. These include left, right, and center, also referred to as LCR, left and right side surrounds, left and right rear surrounds, a subwoofer channel, also known as your LFE, and 4 top surround speakers, which can often be referred to as overhead or height speakers. It's important that your speakers at all locations are matched in frequency response and volume output in order to enable a balanced full range reproduction throughout the mix room. Here are some best practices for placement of the speakers. When measured from the floor to the speaker's acoustic center, the front, side, and rear speakers should be at ear level for a seated mixer, approximately 1.2 meters or 4 feet. In a 914 or 916 configuration, there would be additional wide speakers located between the left and right and the side surrounds. In the renderer, we have the option to change and modify our monitoring configurations. These options include, but are not limited to, 914, 714, 71, 51, 2.0 or traditional stereo, and other configurations. For placement of my front and rear speakers, I used traditional speaker stands. My LCR are Focal Twin 6BE, and my rear surrounds are Genelec 8020Ds. I also use the same Genelec for my overhead speakers and have them mounted to a crossbar with speaker clamps. I used standard lighting truss to section out my room and create rigging points. This allowed me to avoid drilling into my ceiling to mount the speakers and still achieve the recommended overhead heights. My side surrounds are clamped into the truss on either side of the mix position. I'm using the renderer within the Dolby Atmos production suite and tuning my room via the JBL Intonato 24. Within this interface, I'm not only tuning my speakers, but I'm also adjusting the time delays. It's very important to match speaker capabilities in all locations, but it's not uncommon to use smaller surround and overhead speakers, as I've done here, as long as they reach the target SPL, have ample headroom, and meet specifications. My sub is a Focal Sub 6, and my LFE and bass management settings are also controlled in the JBL Intonato 24. Think of your LFE or low frequency effects as your sub crossover. And with Atmos, you have a lot of creative control over this part of the frequency spectrum. Many of the DAWs that now support Dolby Atmos workflows have an LFE feed that can be utilized directly from the multi-channel panner. While this is useful in some circumstances, we definitely recommend using a dedicated send from the channel to a low-pass filtered LFE bus. Let's take a look at how I've configured my signal flow for my 714 setup. Starting with my DAW, which on any given day could be Logic, Ableton, Pro Tools, or any of the other Atmos-enabled platforms, I would set my playback engine to the Dolby Audio Bridge. This may be different if you're using the mastering suite on a secondary machine. From there, within the renderer, my input is also set to the Dolby Audio Bridge, while my output is my main audio interface, which is the Apollo X16. From the Apollo, the signal goes out via a DB25 cable connecting directly to the JBL Intonato 24. This is where I adjust the tuning of each speaker using the parametric EQ system, as well as making small adjustments for time delay considerations. The output from my Intonato is a DB25 to XLR fan-out cable, which feeds signal directly to my speakers. Calibrating your room refers to adjusting the output level and frequency response of each speaker according to the acoustics of the room. There are a variety of speaker manufacturers that you can choose from, but keep in mind that a Dolby Atmos mixed room should be capable of reproducing 85 decibels with an extra 20 dB of headroom from each speaker to the mixed position. When calibrating speaker reference levels, the renderer will send -20 dBFS pink noise signal to a single speaker. We adjust its output level in our monitor system until the speaker produces 85 dB SPL at the mixed position. Additionally, we use EQ to tune the frequency response, and this process is repeated for all full range speakers. For more information on speaker calibration, please visit learning.dolby.com. The Dolby Atmos Music Studio's Best Practices Guide outlines key areas that benefit from room-specific guidance and lays out the expectations for commercial studios as well as private mix rooms. Another great support tool for new Atmos music studios is the Dolby Music Studio onboarding form. Here you can enter your room dimensions and receive guidance and feedback from our studio teams on implementation and designs. Your local reseller will have options for studio configurations at various price points and can work with you on implementation. Check out our list of resellers here. Now I'm going to pass it over to my colleague, Brian Pennington, who will share with us some of his best practices for Atmos music room tuning.
Hello everyone, my name is Brian Pennington and I am a Senior Field Applications Engineer at Dolby Laboratories. Setting up your studio can be daunting, so I'd like to talk about some of the things that you should consider when designing and implementing a Dolby Atmos music mix space. Many of these ideas are in the Dolby Atmos Music Studio's Best Practices document found at professionalsupport.dolby.com. There are a few major points that I like to pass along to people when setting up their rooms for mixing. Basically, a list of things that can really affect how your mixes translate from your mix space to the consumer's listening experience, as well as other professional studios. One of the first things that I like to speak to people about is the size of the room. You want to make sure it's not too big and not too small. Luke has already gone over some of the minimum and recommended sizes, but I can't stress enough that bigger is not always better. You want to make sure that the room is not too big to turn out a good mix. One of the things that we do consider is shape of the room. We want to make sure that you're probably more in a rectangular room, less in a square room, because you can load yourself up with acoustic problems due to the squareness of the room. If you can help it, also try to orient yourself so that you're on the long axis of the room as opposed to the wide axis of the room. One of the next topics that we talk about are usually speaker selection. We try not to endorse any particular speaker manufacturer, as Atmos works with all of them. Keep in mind that price does not necessarily denote quality. There are quality speakers at all budget levels that can work with your budget and your studio environment. We also have a tool named the DART, the Dolby Atmos Room Design Tool. It's helpful for choosing speakers that are right for your space. The DART allows you to put your room dimensions in to a spreadsheet style form, and it calculates where your speakers should go in your existing space. It also allows you to play around with different models of speakers and different combinations of speakers to see what works for your space for both power handling and SPL. When I show up to a studio to tune a room, there are 4 main topics that I think that people should keep in mind: speaker aiming, SPL, setting delays, and EQ. I asked people to follow the recommended speaker placements in the best practices document available at professionalsupport.dolby.com. It may seem obvious, but we ask people to aim the speakers at the mix position. And when you aim your speakers, aim them in an over-the-shoulder style that allows for a wider sweet spot. The next topic that I like to talk about is SPL and level calibration. You're going to want a good SPL meter that can do C weighting and A weighting with both fast and slow responses. You want C weighting for speakers with similar but flat responses down to 40 Hertz. You're going to choose A weighting for speakers with disparate, uneven responses. A weighting is a band-limited measurement that discounts low-frequency content, which can be very uneven depending on the speaker's location in the room and its overall response. A weighting can give you a closer match between speakers if you do not have the ability to tune the room with an RTA. But you're still going to want to check it with C weighting once you've done all of your final checks to make sure that they're closer to each other. To match the levels in all of your speakers, start by generating noise from the renderer's speaker calibration window. Clicking on each individual speaker representation, you'll hear noise out of the different speakers. Make all of these speakers the same volume. The relative volume is the more important aspect here. We want them all to be the same, except for the sub, which should end up around 5 or 6 dB louder than your center channel. 85 dB is the recommended level for professional studio environments. Usually, this is only for final checks and reviews though. Mixing levels are quite often lower. 70, 75, 80 is common in smaller spaces and home studios. It's comfortable for a long day of working and can yield a closer match to your LKFS measurement targets depending on your mixing style. If you find yourself missing your LKF measurement targets on a consistent basis, change your monitoring level so that you're going to more reliably hit your target without having to adjust it at the end with loudness correction tools. The next topic that I usually talk about is setting delays. Setting delays can be as simple or as complex as you feel they need to be. They can be adjusted physically or electronically. Electronically is usually easier, if available, and yields a more refinable result. Physical adjustment can be very cost-effective and practical, but it's hard to repeat because you're physically moving speakers around in the room. Measurements can be made a few different ways. I tend to use transfer functions in Smart to measure delays when I tune rooms because it gives me very precise results. But measurements can be done with a tape measure and a notebook. The method for measuring delay times is to measure the distance from a single point at the mix position to each speaker. This can be easier to achieve with a laser disto or a laser tape, especially for the overheads. But a physical tape measure works just as well. Take the longest measurement as the furthest distance in time. This is usually going to either be the rear speakers or one of the overheads in most rooms. This becomes your base distance or base time. Calculate the time delay based on the distance to each speaker. You do this by using the speed of sound, which is 1,125 feet per second. That translates to roughly 1.125 feet per millisecond. You add the delay to the earlier arriving speakers until all of the speakers are arriving at the same time at the mix position. Setting delay timing can really tighten up your mix. You'll notice that things like reverb start to sound way more cohesive, and that pans will start to sound more consistent and constant as they move around the room. Less like the sound is moving from one speaker to another, and more like a ball of audio just moving around the room. You'll want to be as precise as your equipment allows. For instance, the renderer only allows for whole millisecond adjustments in the speaker calibration page. It may not be the best device for delay adjustment, but it may be all you have. Monitor controllers like the Grace 908 have stepped values that are slightly more precise. Monitor controllers like the JBL Intonato can make adjustments in the tenths of a millisecond. And monitor controllers like the Avid Matrix with an SPQ card, the Avid Matrix Studio, the BSS Blue speaker controllers, and QSys from QSC have the capabilities for adjustments down to hundreds of milliseconds on every channel. The next topic I'd like to talk about is acoustic room tuning and EQ. These are sometimes confused as the same topic, but are two entirely separate concepts. There are a few things that EQ cannot fix and should be looked at before any speaker EQing is attempted. Things like bass trapping to avoid low-end buildup in the room. Corner foam wedges and round diffusers work well to alleviate this style of problem. Then there's reverb time, which can greatly affect your mix translations. RT60 times of around 0.5 to 0.8 seconds are typical of most well-behaved mix rooms. 60-40 or 70-30 is a good rule of thumb to follow when figuring out how much absorptive surfaces versus reflective surfaces you should plan for in your mix space. That includes floors, walls, and ceilings. Too much reflective energy can lead to smearing in nodes with a distinct lack of clarity. But too much deadness can lead to reverbs that disappear in your space only to return with a vengeance in other rooms. Room modes can create nodes at the mix position that no EQ can reliably fix. Resonators and tuned absorbers can absorb some of that energy to help alleviate the standing wave energy that creates such phenomena. There are plenty of DIY tutorials out there that can help solve this kind of problem. But if this all seems like magic to you, hire an acoustician. Rely on their knowledge and expertise to help you fix acoustic problems in your room. I feel like money spent on this type of help will be more valuable than any piece of gear you will ever buy. Rooms with too many acoustical problems will ultimately mean your mixes will have a hard time translating. There are two main goals for EQing speakers: to make the speakers sound more like each other, and to effect a better translation of your mixes from your mix room to the consumer listening environment and to other professional studios. When tuning your room, use what's available to you and start with the built-in speaker filters. Set the filters to match the conditions that each speakers are placed in. For instance, you can drop the bass a notch if it's against the wall. You can drop the bass another notch if it's in the corner. Try to use the filters to match the timbres around the room. One technique is to play pink noise from the Dolby Atmos renderer in rotate mode to pick out which speaker positions might sound too bright or too bassy and make adjustments as you hear them. You can also use your monitor controller's EQ function if it has one. If you're using the Dolby Atmos mastering suite, you can use the built-in EQ as your last option. It's a really good third octave EQ with some bulk filter shaping at the top and bottom, but it can add strain to a computer that might possibly be running on the edge. If you have the capability, knowledge, and opportunity, tune your speaker system with a set of microphones and an RTA. A single microphone is not necessarily good enough for an accurate response of readings below around 500 Hz. Also, a single mic position is not necessarily good enough to accurately predict or identify room modes that could be affecting the timbre of a particular speaker. Systems like Smart allow for averaging of multiple microphones at once for a more comprehensive picture of your speaker responses. We want you to try and adhere to the Dolby Atmos Music Curve discussed in the Dolby Atmos Music Best Practices document found at professionalsupport.dolby.com. I'd like to wrap up our conversation with 4 pro tips. First, we'd love it if you would cover your speakers. Creating a room where you can't see your speakers will improve your mixes because you'll stop mixing for speakers and start mixing for the space that you're in. Second, we want you to tighten up your room acoustics with improvements. If your room is fundamentally flawed, your mixes will be too. Third, take a field trip. Mix stuff in your room and then go see how it translates to other known Atmos spaces. This is especially useful if you are going to work with a particular pro studio for purposes of reviews with clients. And lastly, if your mixes are not translating well, work hard to improve your setup so that those mixes do translate better to the known Atmos playback systems. If they sound wrong in someone else's room, you know you have some homework to do. Thanks for watching. I hope these videos have helped you set up your Atmos mix room, and I can't wait to hear your Dolby Atmos music mixes out in the wild.